Okay. There we go. Okay. There we go. That's okay. I'm just muting the YouTube because it'll come back through that.
Good evening and welcome to Highlands Astronomical Society, live lunar observing webcast brought to you from Benview Observatory, Connan Bridge in the Scottish Highlands. My name is Eric Walker and I'm the lunar scope pilot for tonight. With me is my co-host Dave Davidson, part of the Highlands Astronomical Society observing team, and anyone and everyone that attends our monthly meetings will know that Dave cannot possibly have a monthly meeting without at least half a dozen, if not a dozen, lunar photographs. Dave, one of our most expert lunar photographers. Dave, you want to say a few words?
Hey everybody.
short and sweet.
Welcome to the 21st of February lunar observing session, live from Inverness in Scotland.
Well, you'll be pleased to know I have at last got a clear sky, and the moon is right above us, just past the south mark, so it's there for all to see. Now, what are we going to be looking at tonight? Well, Dave, I have selected a few little targets, but first of all I'm just going to go through some of the big things when you're observing the moon. So the first thing is I'm going to talk about the phase of the moon, just in very, very general terms. The terminator, which is extremely important to lunar observers. And also, when we're looking at the full scale, the big moon, I'm going to talk about the mare or the seas. Now, this phase of the moon is the first quarter. It's just past the first quarter in actual fact. We're about 10 days into the moon cycle, and the moon is illuminated about 69%. So 69% of the moon's disk is actually illuminated. And the moon is illuminated by the sun. There's always a half, 50% of the moon is illuminated by the sun, but depending on where the moon is in its Earth's orbit, depends on how much of that reflected surface we can see, and that portion that we can see is what we call a phase. So this is a shot from a free online, it's a free bit of software actually, called Virtual Moon Atlas. I currently have it on my laptop, but I know you can get it for your smartphones, and it's free as far as I'm aware. I'm sure there's paid for versions as well if you don't want adverts and things, but this is the app that I use when I'm doing my lunar observing. Whether I'm planning it or whether I'm trying to identify a feature, I'm not quite sure of. Now, this slide, this shows you the moon, its full phase. So this is a full moon, but in actual fact, we're not at the full moon. As I say, we are just past the first quarter. The first quarter, of course, is actually a half. The phases, the big phases of the moon are new moon, where there is no surface of the moon lit that we can see from the Earth. The first quarter, which is half the moon lit, and as we are looking at the moon, it's the right hand side that's lit. You then have the full moon itself, so 100% of the moon is lit. You then have the last quarter, where the left hand side of the moon is lit, and then a few days later it goes on to the end of the cycle, or the start of the new cycle, the new moon again. Now, the important thing with this, the phases of the moon, is that the terminator, so this is the area of twilight, the area between sunlight and shadow, and this is the bit that lunar astronomers use. We can see so many features highlight at this terminal point. Here's a couple of astrophotographs taken. So this is showing the first quarter moon, the half moon, lit from, as we're looking at it, the right hand side by the sun. And what that does, just go back. What that does, you can see the sunlight coming in from the right hand side, and look at this crater here. Now the rim of this crater, there's actually a huge mountain on the side. If you can see it, it lights up the side of the mountain, of the peak, and casts its shadow into its floor. So that's how we know what the actual the relief of the features we're looking at. You can see the inside of the crater wall is sunlit, so it's reflecting it. And at the terminator, it really helps show the relief of the features. So I'll be spending almost all of my time here. Actually, Dave, I'm just looking at this picture that I've got, and remember we were talking today about the two little craters.
Yeah.
The Messier craters. Can you see them here? These two craters with the I don't know whether you can see that with the rays.
The
Yeah.
Uh-huh.
Yeah.
Mm-hmm.
Sorry, that's a little private conversation Dave and I had, but these are we were talking about crater formation and how they formed, but I'm not going to dwell on that.
A good way to explain the phases of the moon and kind of work it out for yourself is just take a football into a dark room with a torch and put the torch on the counter and shine the torch on the football and let it spin round. You'll see as you move your position, the phases will just be created, as the torch shines on one side of it. You get your half moon, put it behind it, you get a new moon, face it straight on, you get a full moon.
Cool.
Just explains how the phases work.
Yeah. Now,
the moon between the sun and the earth. So it's acting like a torch shining on it. You're in a fixed position, and as the moon goes round, it changes its phase.
Now the other
You're
thing
right about that is where all the relief comes from. That's where, in fact, that's where a lot of our understanding of the heights of some of the crater rims and the mountains comes from, because only there do they cast shadows, and the shadows can be measured relative to their distance that they spread away from the edge of the crater. And you can use trigonometry and things like that to actually calculate the height that the peaks spread the shadows out over. Like trees on an autumn afternoon. They cast long shadows or short ones depending on the height of the sun.
So learning trigonometry at school, Dave, is actually useful.
Didn't work for me, no. I use a calculator.
Now, the other thing I forgot to mention is not just about the phases, but something, I mean, I'm sure everyone knows, it's the same face of the moon, the same side of the moon faces us all the time. So why is that? It's because the moon is tidally locked to us. I'm going to just give standard numbers here. The moon takes about 28 days to orbit the Earth. It also takes the same time to spin on its axis. That, by definition, means that the same side faces us all the time. There's another term you may have heard used called the dark side of the moon. It's actually the far side of the moon. Many people think the far side of the moon is dark all the time. It's not. It's lit just as much as this side is. So it's just a term. Useful in songs, though, Dave. Song titles. Now, so before we actually go on to observing the moon proper through the scope here tonight, I'm just going to show you some things to look out for, and these are these big mare, the big seas. Now, they were thought of as seas in days long gone by, but of course they're not seas. But these are areas which they're like flooded lava basins, and they've got high iron content. So they're dark. They don't reflect as much as the highlands or the mountains do. So they're called sea, and of course they're called Latin just to find another useful school subject.
Actually, strangely enough, here's an interesting thing about the features and the names of the features and the craters on the moon. In 1609, late in the spring of 1609, Galileo looked at the moon and saw, the first time beyond what you could see with your eyes. You could see that there were craters on the moon, that there were these dark, dusky areas, which they thought at the time were seas. And as the century wore on towards the end of it, towards the end of the 16th century, they were all given. Each of these craters were given, as the ones they could see, were given names. Oddly enough, they were given names from terrestrial objects, and it was only after the close of the century when what they called then selenography, that was looking at the moon, became more possible because of the advancement of telescopes. A chap we called Hebel of Danzig and Scheiner Langrenus, who was what in those days called cosmographer to the King of Spain, which is what we would now call astronomer royal, that type of thing. And Riccioli, who was a Jesuit astronomer in Bologna, and Dominic Cassini, who the Cassini division and the rings of Saturn are named after. Anyway, they started to name them after terrestrial features, and it wasn't until later in that, at the end of the century, that they were changed by a guy called can't remember what his name was. Italian chap. He changed all the names to the names of mathematicians, scientists, and celebrities of the day, and that's what they are today. They were previously called, after mountain names, like we would hear, like we've got Ben Nevis, Ben Runas, that sort of thing. They were all called that after those set of names. What you might like to know.
Yeah. Well, as you can see here, we have the big mares, the big seas: Mare Imbrium, the Sea of Rains; Mare Serenitatis, Sea of Serenity; Mare Tranquillitatis, that's the Sea of Tranquility, and of course that's where Apollo 11, the first manned moon landing, landed, just down roughly in this area here, where Neil Armstrong and Edwin Buzz Aldrin took the first human steps on the moon. The Mare Crisium, Sea of Crises, that makes a wonderful picture in a 1 or 2 day old moon, doesn't it, Dave? You like that picture, I think, when you get that. Mare Fecunditatis, the Sea of Fertility.
Yeah, Fecunditatis, yes.
That's a sea. Yeah, Sea of Fertility is easier to say. Mare Nectaris, Sea of Nectar. Mare Nubium. Is that Sea of Sorrow? Can't remember. And then you get the sinuses, which are bays. So the Middle Bay, and can't remember, there should be another one somewhere. Sinus Asperitatis, the rough.
Iridium, isn't it?
Yeah, the middle. That's the Middle Bay, and that one is Asperitatis. If my Latin's right, it's roughness. I think Sea of Rough, Bay of Roughness. I think that's what that means. Anyway. Without further ado, I think, Dave, we should head on to the live view. So here is the live view. I'm hoping you can see that on Zoom, Dave.
Wow. Oh, yeah. Oh.
You see it? Okay.
Terrific, yeah.
Okay, so it looks pretty much like that idealised map. I've got a tiny little bit of light cloud going back and forward in it, so it'll jiggle about the Terminator. You will notice that the Terminator is not quite as clean cut as that bit of software shows. Okay, I can probably up the exposure a little bit, take some of that out, but I was trying to show you the seas. There you go, look. You see the seas? There's the Mare Crisium, Sea of Tranquility. Okay, Sea of Fertility. There, is that quite clear, Dave? Is that showing up okay?
I keep going with that a wee bit if you can, just to get the contrast out of that.
All right, okay. I'll try and I'll put I'll overexpose the right hand side a bit to get the Terminator. If that's actually not bad, is it?
That's pretty good, yeah.
Yeah. I'll zoom in. I'll go in. There we go. How's that?
Perfect.
Yeah.
Especially if you're going to be just looking primarily at the edge for the shadow there.
Now, I do have for Dave and I's use slides for guiding us through objects to watch with some facts, just to kid on that you're the experts. Now, that big crater that you're seeing standing out at you, you see it here?
Yeah, the one that's
yeah, that is Copernicus. Very famous crater, one that you can actually see very easily, obviously not in so much detail, but you can see it very easily with a pair of binoculars.
Absolutely.
Yeah, and it's actually quite a young crater, Dave, and it's regarded as having almost a hexagonal formation about it rather than circular. I don't know how they work that out, but it always looks circular to me in any photographs I've taken of it. You will notice it's got very, very bright rays emanating from it. You see them? Now, those are actually more evident in 2 or 3 days' time. You'll see them all the way around, and you can just imagine something in space has hit the moon square on at tremendous velocity, and it's thrown out masses of ejecta and caused, brought about those rays. So it's brought some stuff out from, just, under the surface and scattered it in rays all round about the actual crater itself. It has very, very steep slopes up there. You can almost imagine, like a volcano, but not quite as steep as a volcano, but they're very steep slopes on the outside. They're about, I think they're 900 meter slopes, something like that. There are inside it. Can you see? I don't know whether you can see at this scale. Can you see that there are actually three central mountains inside it? Can you see that, Dave?
I can see it, but then I know that they're there.
Yeah,
I've to zoom a wee bit.
Okay, I've zoomed in a bit. It's just starting to pixelate, but I don't know whether you can, and there's a little bit of movement in it. That's just the turbulence of the atmosphere. Can you see it? Maybe.
Yeah, see that there's a central
mass
in there.
Yeah. Oh, there's Rona. I've just noticed the chat. Rona's going. She's now. She's linking the 900 meters to a Monroe size almost. That's actually very useful. Very useful to get a kind of handle on the scale. Those central mountains. Those central mountains are about 1,200 meters high. So just trying to think what that is. That's it's roughly 3 and a bit feet to a meter.
I don't do meters.
So it's probably a bit bigger than Ben Wyvis, probably nearer Cairngorm size. If I'm right, Rona. I'm hoping I'm getting my calculations right.
They're pretty high, I think. I think they're more than that.
Okay. Somebody's just asked, when did the crater Copernicus form? I don't know off the top of my head, but perhaps somebody watching knows. As I say, the general description is it's young. So it was formed, after the.
Well, I think it'd be fair to say that presupposes that the impact theory is the current thinking.
Yeah.
The impacts were never in the beginning of lunar observations. It was they didn't figure that they were impacts at all. I mean, they were either volcanic or there were some unusual thing which was unique to the moon.
Because
they're not all easily explained by impacts. Some of them are hexagonal. Some of them are stretched out. Some of them are some of them don't have central points. Lots of them do. Some of them are sort of cone shaped, or very, very flat indeed. And also, what's very prevalent on the craters on the moon is impacts on the rims. There's an enormous number of craters where there are craters within the crater rims of the larger one. So, you've got to ask what are the chances of that? and why they don't destroy the wall of the crater rather than make these impacts.
Yeah. Actually, Pauline's...
Sorry,
Pauline's just typed in, she says about 1 billion years ago. So it might be young, but it's no young to us. Oh, and I've just seen who asked the questions. It's Hermione. So welcome, Fruitsy. I know that is your moniker. Well, there's a debate going on already about the formation of the moon, Dave. That's very healthy.
Well, I mean, it's right to say that the current scientific understanding is that there was, they call it there was a late bombardment of the moon, which caused the larger part of the craters, which is to explain the reason why some craters look weathered. They look like they're worn away, and other ones that look like, you can see on your map, our live image there, Copernicus looks fresh, if you like. It's crisp and clear, whereas the craters to the right and lower of that are almost flat. I mean, given that there's less relief there, but the walls of these craters are much lower, and in some cases they look like they're almost buried in the. So either there was bombarded several times, or it's a different explanation how they were created in the first place.
Yeah. Now,
if you look up from Copernicus, you'll see what is called the Apennine Range of mountains.
The Apennine Range, yeah.
But technically speaking, they're not the same as the mountains you would see here, which are they're caused by pressure and upheaval from different angles. Now, if you follow the line of those,
is that this here, Dave?
No, further up. If you go up to Copernicus and there, that forms almost a circle.
Oh yes, yeah.
It gets less pronounced. But you can see that there's an enormous ring.
Yeah. I've just reduced the exposure just to try and bring that out a bit.
Oh yeah, so you can see.
Yeah.
See here that.
Yeah, so there's something caused that as well. Yeah, definitely. There's a few of these on the moon, in actual fact, Dave. This type of feature, isn't there?
If you imagine that the moon is roughly the same size as China, that something impacting the surface of China that to create that size of a crater were an impact crater, you would think we'd just destroy it and split it into asteroids. Food for thought.
Right, I'm going to try and find another thing.
Plato should be above you there, which is a really.
Oh, Plato, I can go that way. Yeah. Well, in fact, there it is. I can see it there. Look, I'll bring it.
Now, this one's fascinating to look at, whether we understand anything about it whatsoever. But the floor of this crater is almost flat as a pancake, and almost no impact in there. It's just like it's completely flat. Difficult to see there, but you can see, yes, there. You can see that it's got a very flat floor and a perfectly circular outer rim.
Yeah, Plato, Dave. I'm just reading about Plato, right? Yeah. So it is a circular formation, right? So yeah, it's a crater, but it's crushing. It's right up against that chain of the Alps that you were talking about. It's crushing it right up against it. It's actually, here's a little interesting fact. It had something called a transient lunar phenomenon. There were clouds that were observed, or people thought they were clouds, in 1871. Now, for those of you or us who watch our these channels on the digital television, I was watching one of these the other day, and it turned out, there are these. It's more frequent than you think it is, and it's more detectable now, just simply because we have better instruments to look at things. But it turns out, Dave, that these things, that they're nothing more than it's a disturbance caused by like the solar wind, and it just stirs enough of the fine dusty surface, or charges it up just to cause these little transient areas. There are other ones you get flashes, big flashes, which I'm not sure what they are. Don't know whether you do or anybody does.
No, I don't think anybody really knows what they are. I mean, they are disputed as well because they are what they're called transient lunar phenomena. So therefore, only one person tends to see them. Impossible to corroborate, and there's very little, if no, photographic evidence for what they are, because they're there and gone.
Yeah,
However, Patrick Moore was one guy who spent an enormous amount, almost all his astronomical career on the moon. He was one of the guys who really studied transient lunar phenomena. And he saw an awful lot of them. And he had no explanation for what they were. But you're right, they're either bright flashes, misty clouds, areas which are out of focus when they should be crystal clear images.
Dave, I'm just reading the chat again, and there's a lovely little debate going on about the age of Copernicus. People are researching it, and they're saying it's 800 million years ago. Whereas Pauline said it was a billion. Now, if we're talking about a UK billion, that's 1,000 million. So you're only talking about 200 million. What's 200 million years between friends? That's not a lot. If it was a USA billion, which is a million, then perhaps there'd be a bit of a disagreement.
Okay.
And there's Anthony. Anthony says he would love to see a TLP. He's already managed to put that lovely little term.
I've spent a long time looking at the moon. I'm photographing the moon. I've never seen a TLP.
Yeah, but, the other one.
If Patrick Moore says there's TLPs, I would believe it.
Sorry, you broke up there, Dave. I couldn't quite make out what you said.
If Patrick Moore says there's transient lunar phenomena, then I would believe him.
Now, I've got a few more little single line facts about Plato here, Dave. So the transient lunar phenomenon was one. They've actually it's got pretty steep slopes, considering it's very, a flat floor. It's got pretty steep slopes, which, is why I think it stands out so much. It also, it's got a few high walls with 2,000 metre summits and a collapsed part to the west. Sorry, I'm just going to have a look at that, see if we can see that.
Right. Okay. Well, if you would have taken these photographs a day or so, well, yesterday, in fact, the Terminator would have been almost halfway across.
Yes.
And you could see that the edges of the crater spill over the shadows into the flat plane, and they are like needle points.
Yeah.
Literally like sharp, tall, sharp needle point images. You can just see the edge of the shadow on the right hand side of the plane.
I just upped the exposure there just to show that, Dave. So they're actually quite high on that side as well. They
are very high, incredibly charged. They're very, very sharp points.
Yeah, and this one on this left side here, that's the 2,000 metre summit they must be talking about. That's also casting a hell of a shadow. You see it?
Yeah.
Yeah.
Yeah, it's just past the time for really highlighting just how dramatic those cliffs and points are.
Yeah. Right, I'm going to up the Explorer. I just wanted to get the Terminator proper, if you don't mind. It'll expose all the other stuff. now you can see, I don't know, I can't remember, I don't know what all these features are, but can you see how, I mean, look how rough that is.
Uh,
I mean, the
yeah.
moon is not smooth by any manner of means, is it?
And I mean, these things, for example, see down where the logo or the Highlands Astronomical site logo is. Not anymore, you moved it. Some of the peaks of these, the peaks stick way out into the dark. You know, you can see on the edge there that there are pinpoints of light.
Oh yeah, like there.
You went back to Copernicus.
Yeah.
And up and slightly to just right on the edge of the firmament, you'll see that there are sharp points of light in what look like they're just hanging in space.
Oh, these ones.
So,
yes.
you see what I mean? So
yeah.
if you work back from that, in order for that to be illuminated and the floor underneath it to be in pitch dark, they must be of an extraordinary height.
Yeah, I can actually see, Dave. I mean, I've got the big screen obviously in front of me here, but this one, like, standing out in the middle of nowhere.
Yes.
Oh, sorry. I'm just gonna. Can you see that? Looks like it's actually. I can see that is a crater. And that's the high rim. So as you say, those are quite high to be able to be shown like that. So these will be, there'll be crater rims or little mountains or something like that on the top of.
They must be very high points compared to the what's back underneath it.
Yeah.
If you see the Rocky Mountains on the Earth, where the sun comes out or sets, the tops of the mountains are illuminated, and everything else is in utter darkness.
That's right. Well, you can see it here very clearly. Look at this area, Dave.
Yeah, absolutely.
And we know that is a great area to photograph. You get some wonderful astro or lunar photographs in this area. This is a great phase of the moon to be doing that. Taking pictures.
So we've got a range of dates for all these things.
Oh, you always do. You always do.
800 million to last week. Actually, that's an interesting thing. So, I mean, in the lifetime of people looking at the moon, I'm not sure that anybody's ever seen a crater being formed.
No, that's a fair point. Yeah.
I mean, if you think the first time the moon was observed beyond just looking with your eyes, that was 1609. So it was several hundreds of years to study it, with some pretty dramatic equipment.
Yeah, actually, Dave, I'm just realising. See that area I'm highlighting here.
Mm-hmm.
Can you see I'm highlighting it? Yeah. This crater is actually quite an interesting crater itself. It's called Bullialdus. All right, and it's actually it's isolated on itself, and it's on the west bank of the Mare Nubium. It has got extremely steep and tormented, so rough, very rough slopes. It's got very high walls and terraces, so it's like a mini. Well, it's actually no, it's not like a mini Copernicus. I'll tell you the crater it's like. This is one of my favourite craters, which one I photographed with three. It's got three mountains inside it. Is Eratosthenes, just at the edge, the tip of the Apennines, which is maybe visible just now.
Yeah, they look more like they're hollowed out than they're.
Yeah, they look like there's been a marble been flung into a jar of flour or something, don't they?
I mean, one thing you're not being able to see on Copernicus is the terracing.
Oh, I know.
Edges of that. It looks as if these very steep sides have collapsed in several, maybe 3 or 4 different stages, because they go down. It's impossible to see that. From that.
Yeah. If I had my other setup, I would be able to see them.
You could look that up on
Google
or whatever. Yeah, you'll be able to see that the higher point are flat around the edges, and then they're flat again and again
Yeah.
and again. The
I mean,
terraces.
well, they're that steep that the material is basically running down it, isn't it, into terraces?
Yeah,
So
yeah. It's
simple.
it's like enormous ski slopes or collapsed terracing is what it would be geologically described on the Earth.
Uh-huh. Now, am I able, or do we have the crater? Is Tycho there? Have I got Tycho? Is that appeared yet, or is that just too far away?
Might be right on the, if you go down the bottom, it might be right on the edge. Oh, there it is there, look. That's Tycho. There's Clavius is the huge one.
Oh, Clavius is a fantastic one.
Right, so just that from there. That's
sorry, I'm just trying to get the exposure just to bring
it won't be quite so. There we go.
I'll
you can
get
see the central peak in Tycho now, and just you'll be able to see the rays.
Oh, that's Tycho. Yeah, there we go.
Yeah,
that's it there. Yeah, yeah. See, it's just past the Terminator, so it's just you just can't quite see the stuff in it.
You know, you can.
Oh, mind you, I can see the mountain now, Dave. I've got it now. Look, see, bringing it down. Look. Oh.
Aye, just keep going a wee bit more.
Yeah.
Maps. Aye, there you go. You can see the.
There you go. So you see the mountain now.
Yeah. That's a very distinctive peak in the middle of that one.
Oh yeah, yeah.
And it has the same terracing around the edges. Another interesting thing about Tycho that if you look at the rays that spread out from that now, I mean they spread out almost across the entire surface of the moon.
They do. They do.
Almost encompass the moon right up to certainly 3/4 of the whole moon. These rays spread out from.
Yeah, I think
they don't spread out from the edge of the crater rim. If you look very closely at a photograph, you'll see that there's several, a good 50 or 60 miles, if not more, before the rays actually start. So it's clean around the outside of the crater. Then the rays start and spread out.
Yeah. I don't know if this is a geological term. Maybe Ron will be able to tell us, but the description is it's the furnace of the most important radiating system. I think that's what you're describing. So it doesn't necessarily. The furnace, furnace is in FRNACE. It just says it as. So I don't know what. I'm sure that'll be a specific term of some sort. Yeah.
Sure.
Of the most important radiating system. Yeah. It's actually got an interest. The central mountain is one mountain, but it's got 3 summits on it.
Yeah.
Three distinct summits. 1,500 meters high. Again, in a fairly flat floor, but the walls are. They're terraced as well, Dave. You were describing Copernicus as being like that.
Yes. And just to give some idea of the scale of these things, I think that's about 60 miles of diameter of Tycho, isn't
it? Someone would have to educate me on that, I'm afraid.
I'm pretty sure it sounds about it.
I'm sure there'll be discussions going on in.
All right. What have we got here? Anthony says that a TLP is something that he'd love to see.
Yeah. Yeah. Rona's just told me furnace is not a geological term. So I shall bow to Rona's geological knowledge.
Yeah.
Someone who just likes the English language by the sound of it.
Yeah. I always, one of the things I always think about when I'm looking at the moon or taking photos of the moon, you'd imagine that if you're looking at the moon at different phases, different times each month, it would be repetitive. So that you do the same things again and again and again. But oddly, it's almost like you never see the same thing twice, because literally minutes between the shadows changing can make an enormous difference to what it is that you're seeing. If you sit with your telescope, I mean, if you look out the window and see the moon all night long, it's going to look pretty much like what you're seeing there. But if you were to take a telescope and have a very close look at the edge of the moon there, you would find that these all these craters that are in shadow, in an hour or so, they'll be half filled in, fully filled in, and the aspect of all the relief will change quite dramatically. So it changes everything, the way you see it.
Yeah. Well, there's a feature I quite often try and go for, which is called the X on the moon. And
Yeah,
that's the sort of joining point of about 4 craters, I think it is.
yeah,
And it lasts. Oh, you're lucky if that lasts about. They say about 3 hours. You know what? To photograph it, you're lucky if it lasts about an hour and a half.
oh, sure.
So that's exactly what it's just like. The sun coming up. The sunrise, and very quickly the shadows change, or sunset. The shadows change so quickly in that last period.
I would say it's unpredictable enough that if you were challenging yourself to find and photograph that X, you'd have a hard job doing it. You're more likely to catch that by luck rather than judgment.
Yeah. Now you mentioned earlier, Dave, that lovely crater Clavius. Now that's a lovely photographic object, isn't it?
And again, another very enigmatic looking structure. It's filled with what looks like something has bounced across the center of it. It starts off with a big ringed plane, which we need to call a crater because that's how we describe.
Uh-huh.
But in the middle of its flat floor, ostensibly flat floor, it appears to have, let's call it an impact at the outside of it. It's followed by about half the size of that dent next to it, and then gradually diminishing smaller ones until it just disappears.
Yeah, that dent next to it, Dave, is actually a crater called, is it Baliantus? I can't remember.
Yeah.
It's actually a crater, like in a few hours' time, Blancanus, that's Blancanus or something, yeah. That will become a distinct looking crater in just an hour or two, rather than that deep, funny, deep looking hole. But again, that shadow shows you how steep those walls are.
Well, exactly. Yeah.
And look at this. There's something. Look at this. Can you see that shadow, Dave? And then there's that, that very bright point. Can you see that?
Mm-hmm.
So there's a feature. There's probably a feature. There's probably a high peak, and a gap or something over here on the edge of this.
That's what I was saying. When you look at the moon, how things change so quickly. Right, just adjacent to Clavius there is what appears to be an enormous pear-shaped shadow. So if you try and extrapolate what the shape of the object that's making that shadow, it's not circular by any means, is it?
No, it's not at all. Oh no! Now, can you remember? I was up at Orkney Science Festival. God, was it 3 years ago now?
Was it as long ago as that?
No, and there was one of these great big inflatable moons that was displayed. The Skiren Moon, it was called, the Glistening Moon, and it was displayed in Stromness Academy's Games Hall.
Yeah.
And right, I know the moon reasonably well, because I observe it and I photograph it a lot. Well, when you see it big and it's in a globe, you try finding the features because they look nothing like what we only see them in 2 dimensions. Yeah, and that's the only picture I have in my head is this 2-dimensional thing. When you see it in 3D, it was panels from the Lunar Reconnaissance Orbiter. It was high resolution photographic panels. So you're my goodness, I really had a job, but it was fantastic to see it and make you realise that it is 3-dimensional and not 2-dimensional.
Yeah. It's only really when you look at what we're seeing now on the edge of these shadows that you appreciate the.
Yeah, I'm going to up the exposure just to see if I can bring that out.
Most moon maps are of the full moon. And so there's almost no relief on the craters. So if you're trying to find anything using a moon map, it's almost never what you see. So if you're looking at a full moon, there's almost nothing to see anyway because the craters are so lit overhead and there's no shadows at all.
It's all washed out as well because the light's flat onto it. Yeah. I'm just reading the chat again, Dave. There's Steve Walker says you've tried to get the Lunar X 6 times and not got it yet.
Well, yeah.
You just part of that is because the weather goes against you as well. See if you get cloud just for that couple of hours, you've had it. You've got to wait a full month to get it again.
I literally think it's what you said. It only lasts for a very, very short period of time.
Yeah.
And you'd have to be pretty lucky to do it.
Yeah. Now I'm going to try and find some. My favourite craters. There's 3 craters that are grouped together, Dave. Where are they? I think they're. Hang on. They're just. I know where they'll be. I know exactly where they'll be. There they are. Can you see them here?
Which ones are you talking about?
Right. There's Archimedes. See that one? The flat one. There is Aristillus, that's that one, and the other one is called Autocyclus. These are also quite good photographic objects if you get them just at the right light. Archimedes there, that's quite a big, that's a fair-sized flat-bottomed crater, and it again, like Plato. It actually has, pretty high walls, and they're also in terraces. They're extremely steep, and it's a flat floor that they reckon as well was filled with lava, Dave. So again, there's various stages of the moon, formation. There's been, there's like you were saying with that big rim, and then there's within it, there's been another crater formation somehow. And then that itself is flooded with lava. So various stages of things.
Well, yeah. Generally speaking, the first question you want to ask is, if it's filled with lava, where did the lava come from? Where did it get in there? Does it come from inside the crater, or did it flow in from outside?
Well, that's an interesting question, because there's other features which there's not so many here tonight, but the rills, the open, I call them exposed. They're like all exposed lava sewers, for want of a better word. So lava did flow over substantial distances, and then these tubes have eventually they've collapsed. In fact, was it not Apollo 15? They sent the mission to Hadley Rill, and they've got a guy. They've got I can't remember which astronaut it was. Scott, was it Harrison? And he was standing beside the lunar rover just at the kind of the end of the rill, and it looks like a big gun barrel, not as wide as I thought they were, because you can get a sense of scale from having the lunar rover vehicle and the astronaut in it, or the lunar not.
I mean, they must be pretty big, because you can see them with an 8 to 10 inch telescope will easily show you.
Oh yeah.
It just looks like a winding stream. You can maybe point that out, its position, for anybody that wants to have a look.
Right, so Hadley Rill, just hang on. I'll find it on my lunar map first, okay?
I'll guide you in if you want.
Okay, hang on.
You were almost sent.
I was there actually. I know. That's right. I was. It's about here. That'd be about right.
No. Put the there. So right, stop. There. So.
Yeah. Sorry, I'm just kind of going round it. Yeah.
Hardly will. So anybody that wants to have a look for themselves, would be able to see that.
Yeah.
With 8 to 10 inch, I would say.
Yeah, there's a little bit of movement in the atmosphere tonight, so I can't quite get the focus, but yeah. But that would have been where Apollo 15 landed, was it in here, somewhere about here?
Yeah, there's a little notch where the
Yeah.
See, there's a dusky bit and then a straight dusky bit underneath there. Yeah.
Yeah.
So it's
About
pretty
here.
much
Yeah.
right in between those two
Yeah.
bits.
That was quite a mission. You know, the other ones took the safe options of landing in large
Yeah.
flat areas, whereas this one came in, and I think it approached, and
Yeah.
it went like that, and then up the valley. Basically,
It's fine.
they got so confident with their that now the electronic or radar navigation systems that they started to take not risks, they took calculated risks because they wanted to turn them into proper geology missions, rather than just I've landed here, kind of thing. Yeah.
Yeah. So yeah, hardly will. It's funny, isn't it, that at the beginning of lunar observation, the first look at the moon, the first judgment was that it was water that created all these features. Everything's called a sea, it's called a bay.
Yeah.
These rills are very similar to water flows. I mean, they do that meandering thing. They're obviously a liquid flow. It's all that on Mars they're always referred to as water flows.
Yeah.
Whereas on the Moon they're lava flows.
Yeah. Yeah. Yeah, and I have to say the Mars pictures, from the Mars orbiters that you see, they definitely look at where Perseverance landed the other day, Dave. That definitely looks like a big river delta, landing in the crater lake, so to speak. You can definitely imagine, you can almost liken it to what you see here on Earth. But yeah, strange.
Absolutely. You can see the correlation between these things. If you on the Moon, in some of these mare or bay areas, they do have features which are very similar to Earth-like geological features, like dried up seabeds. Seabeds tend to go in, like if you go from here up to Culloden Moor and imagine that the sea, beyond, pre-glacial or whatever, if the sea levels were high, you can actually see the seabed terraces as they drop down to the Many Firth now. Yeah. And that is kind of what you see on the Moon at the edges of these. They look like almost folds.
Yeah. Pauline is just reminding us on the chat that the Mars Perseverance craft has landed exactly where it landed because the area is of such interest, because of what we have just discussed, and that there may be some, they're hoping that there may be some traces or chemical traces of, the equivalent of microbial life, that we would find on Earth in those areas. So, yeah, quite fascinating. Right, Dave, I have just put the full picture up again. What I'm going to do, because I'm going to close down the session shortly, but if anyone has any comments or questions they want us to answer, or people that are on the YouTube chat, this is now your opportunity to fire them in, and Dave and I and some of the observing team that I can see are on the YouTube chat will have a go at answering. Oh, have I just timed this correct? My goodness. Did you see the picture just vanished?
Yeah, it's got cloudy.
It certainly has. My goodness. I'll bring it back now. If it comes, this is me really up. Well, when I say up in it, actually, I'll tell you what it's done though. It's made it much more stable.
Aye. Oh yeah, yeah.
Something that's actually a better.
Yeah.
The trouble is the cloud density, the cloud thickness is moving quite a bit.
That's.
I'm just going to go into Copernicus there, if you don't mind. I'm going to.
Well, I mean, to be honest, we've been pretty lucky, to have a live session and actually see them.
But the moon's a great thing. The moon is a fantastic object to observe, whether it's with a big telescope or binoculars. It's just a superb.
It's an undervalued astronomical thing. Normally most astronomers are all amateur astronomers all saying, "Oh, the moon's out tonight, can't even do anything."
Yeah, yeah. They talk about it as a negative thing rather than
As a
it's actually
negative thing.
yeah.
When in fact, the sun and moon are the most. You would imagine they would be the most studied things because they're so close to it.
Yeah, Polly's just rubbing it in that there's no cloud in Inverness, so that's obviously the place I should have moved my observatory to tonight.
Yeah, I know. Very remiss.
So,
I think in the future of these things, so Eric, what we can have is several telescopes running at the same time on these missions, and we can switch to screen shares from other people's live views. I mean,
we would just need to allocate someone to probably produce that show, but it's certainly feasible. It's certainly feasible. Right, Dave. Well, we've been going for about an hour.
Yeah, really.
So, I'm just going to flick us on so that people can see who they've been. Just remind them who they've been talking to again.
Is there any questions that need answering?
I haven't seen any. I haven't seen any coming in. Thank you both. Excellent as always. I'll take that. That's rather good. But, it's really nice being able to bathe myself in sort of whiter light than the red submarine type light that I'm normally in.
Not so cold as the last time you sat there either.
Oh no, I have to be careful. That was I really did get cold. Right. Well, without further ado, I am going to close the night. There's a 2-minute run out. There's a 2-minute countdown in this slide. So if people want to make final comments, or want links for anything, we've got 2 minutes in which we can attempt to help you. But thank you very much for watching this Highlands Astronomical Society live lunar observing webcast. Wishing you clear skies and keep looking up.
See you next time. That the YouTube stop running, is it, Eric?